Welcome to group number 9. Today we will have a look at partial fraction expansion, focusing at repeated roots. So what are partial fraction expansion? Partial fraction expansion are the representative of complicated fraction as a sum of simple fraction. So for today we will have a look at two examples. One is a simpler one and another one is a much more complicated one. So have fun.
So let us see example number 1. The question is ys equals to 3s plus 1 over s plus 1 square, which is a repeated loop. Then we expand it into a partial fraction with the coefficient a and b. Next, we multiply all the terms with the denominator. After that, we cancel the same term and we got this equation. And proceeding with the comparing the right side and the left side equation, and we finally got a equals to 3. Put the value of a into the equation and we got b equals to -2. And finally rewrote all the question with the value of the coefficient.
So let's look at the next example. The ys is equals to s minus 2 over s squared times s plus 1 squared. So let's look at the denominator here. We have two repeated roots which are s power of 2 and s plus 1 power of 2. That denominator we can expand it into 4 terms with 4 coefficients which are a, b, c and d. After that, we multiplying the denominator with all the terms and we simplify the equations into these equations. So let's take s equals to -1, and after substituting the s equals to -1 into the equations, we can find that the value of d is -3.
We substitute s equal to 0 into the simplified equation. Then we get b equal to -2. Then we substitute s equal to 2, b equal to -2 and d equal to -3 into the simplified equation. Then we simplify the equation to get another equation which is c equal to 30 minus 18a over 12.
So let's take the last substitution as s equal to 1. Put s equal to 1 into the equation and we know that b equal to -2 and d equal to -3. Put in the value and we simplify it, getting the equation 2. From equation 2, we substitute equation 1 into equation 2. And then we get a equal to 5. And put the a equal to 5 into the equation 1, we get c equal to -5. Lastly, we put a, b, c, d, the value, into the original expanded partial fraction, we get the final answer.
It's our party, we can do what we want. It's our party, we can say what we want. It's our party.